Hello everybody and welcome to lesson 3-2. We're going to talk today about congruent figures and congruent triangles. We say that two figures are congruent if they have the exact same size and shape. Their orientation does not matter, but all of their corresponding sides must be the same length and all their corresponding angles must have the same measurement. So for example, I've got three triangles down here, triangle DEF, and each of these triangles is congruent to the other triangles despite the fact that they're all at weird orientations. So here, all angle D's are congruent and all sides FE are congruent, and so on and so forth. All the DEs are congruent to each other, and all the DFs, angle E's, and angle F's. So, orientation doesn't matter, but there are so many different things that have relationships in a pair of congruent triangles. Let's take a moment right now and write down all the things that are congruent in these two triangles. So here, I can see that angle A is congruent to angle X because they both have three rings. Angle B is congruent to angle S, and angle C is congruent to angle G. For the side lengths, I can see that AB has one tick mark, so it's congruent to SX. I want you guys now to fill in the last two, okay? Because all the corresponding sides are congruent and all the corresponding angles are congruent, we can write a final congruence statement. That shows that the two triangles themselves are congruent. So here, I say triangle ABC is congruent to. Now before I write down what it's congruent to, I have to take note of the order of the letters. Angle A has three loops, so the first letter I write down over here must have three loops, so that would be X. Angle B has two loops, so the two loop letter must go next, that's S. And angle C has one loop, so I'd write down G. So it's really important to notice that the order actually matters. We have to list the corresponding parts in the same order on both congruent statements. So, key idea right here, guys. It would be wrong if you wrote GSX as opposed to XSG. Order does matter. We also have a theorem called the third angle theorem. What the third angle theorem states is that if two angles of one triangle are congruent to two angles of another triangle, then the third angle is congruent as well. And this makes complete sense because there are 180 degrees in a triangle, and if you know two of the angles of both triangles to be the same, then what is left over has to also be the same because they have to ultimately all add up to 180 degrees. So let's take a look at how we would prove this. So we've got my statements and reasons, and we start off with our given. Angle F is congruent to angle X, angle E is congruent to angle Y. That's a given. And things that are really useful in triangles, the triangle angle sum theorem is probably the most useful thing we have when it comes to triangles specifically. And so I'm probably going to use that. And because the triangle angle sum theorem deals with addition, I'm going to need to convert all of my congruent statements into equality at the very beginning of this proof. So measure of angle F equals measure of angle X, and measure of angle E equals measure of angle Y. Both of these are by the definition of congruent. So now I am going to think about the angle addition postulate. So I know that the measure, oh, I shouldn't have scrolled up because now I need to see the whole triangle. Measure of angle E plus the measure of angle F plus the measure of angle D must equal 180, and the measure of angle X plus the measure of angle Y plus the measure of angle Z must also equal 180. Both of these are the triangle angle sum theorem. And let's keep going. I see that now I have two things that are equal to the same thing, so they can be set equal to each other. Measure of angle E plus measure of angle F plus measure of angle D equals measure of angle X plus measure of angle Y plus measure of angle Z by the transitive property of equality, because we're in equal signs. Now, I can make some substitutions at this point. I know that F is the same as X and E is the same as Y, so in this first piece here, rather than writing E, I could write measure of angle Y, and rather than writing F, I could write measure of angle X. And then I still have my measure of angle D, just like before, equals measure of angle X plus measure of angle Y plus measure of angle Z, and that's two substitutions. So substitution, P-O-E, but it's twice, times 2. Okay. Then I've got some nice subtraction that could happen at this point. I've got angle X on both sides, and I've got angle Y on both sides. So when I subtract, I'm left with the measure, hello, right please, measure of angle D equals the measure of angle Z. Oh my gosh, why is that not writing? Sorry, folks. Z by subtraction. P-O-E. Okay. Then, I'm not quite there yet. I'm so close. I'm supposed to prove that they're congruent, not just that they're equal. So I'm left with angle D is congruent to angle Z by the definition of congruent. So we have proved the third angle theorem. Then, finally, we also need to be able to use third angles to find missing values. And the third angle theorem is really useful because it means looking at this triangle right here, I can see that X is the same as F and E is the same as Y, therefore D must be the same as Z. And I can find the measure of angle D pretty quickly. I do 135 plus 29, and I get that that's 164. Therefore, measure of angle D must equal 180 minus 164, which is in fact just 16. So angle Z, 3x plus 1, must also equal 16 by the third angle theorem. So 3x must equal 15. So x is in fact 5. And we're done with that. All right, guys, I want you all to save this page for in class. We're going to look at it after the class activity. It won't make any sense to you right now, but it will in a bit. So go ahead and do the MML assignment. Make sure you've done that one really, really short try me, and I will see you all in class. Thank you.